Yes, welcome to lesson 2 of the computation of the mode. And this time we want to look at the computation of a mode for a continuous series. Now I'm sure by now you know the difference between continuous series and discrete data. I think by now we should be able to get those clear differences. Now for a continuous series, what we need to understand is the fact that there is a formula for getting the continuous series. Yeah, I think I'll just go directly to the equation. Now we are saying that it is L plus F1 minus F0 divided by 2F1 minus F0 minus F2 times I. Sometimes some books have said it is L plus Fm minus F0 divided by, this is F0 please, by 2 Fm minus F1 minus F2 times Ci. Basically these formulas are just the same. It depends on which book you're using. Now in our case here we are saying F1 is the frequency of the model class. F0 is the frequency preceding the model class, the coming before the model class. And F2 is the frequency following the model class. I is the class interval of the model class. So whether you're using this method or this method, see, we're just saying that this is this is F0. So you have got Fm minus F0 over 2Fm minus F1 minus F2 times class interval. Basically these formulas are just the same. They are the same. I think I have to remove this blue and remove this red. This formula is basically the same. Now I insist that L is the lower class limit of the model class. So our task is basically just to compute having known other. Now whenever you have that data, you have to identify which is this class that has the highest frequency. Then from there you can know what's the preceding frequency of the model and the preceding frequency of the model class. And I think that can be explained using this example. And I want us just to look at this example. This question is saying the following data, from the following data, calculate the mode, actually is the model age. So I would just say the model age. Now these ages ranging between 20 and 60, and we have their frequencies. Now just looking at mere inspection from this data set, understand one, that the data has been arranged from lowest age to the highest age. Number two, that 180 is your highest frequency, and the class is 40 to 45 years. So now using this formula here, we are saying F1 is the frequency of the model class, or if you want to call it Fm, whatever. So now this is your F1. Now we are also saying F0 is the frequency of the preceding of the class preceding the model class, frequency of the class preceding the model class, that is F0. So what is preceding, what is coming before 180 is 150, of course. So this becomes, let me use a different color here. Let this be our F naught, and then F2 is the frequency of the class succeeding or preceding the model class of the class. This word should be a class. So where is our computation? So this is F2. And what is the class interval? 45 minus 40, which is 5. So now we come here and execute the values. I'm sorry for this highlight. Just a minute. Thank you. So we just come and substitute. We know that the value here is that was our formula. Remember, if you can get the formula, it's important that we get it overhead. So you have your lower class boundary. We said it was 40 to 50, and so the lower class boundary is 40. Our class limit, the frequency is 180, F naught is 150, this is 120, and I is 5. So you simply substitute. So 2F1, if our F1 is 180, so it's 2 times 180 minus 150 minus 120 times 5. And if you compute that, this and this, you know, is 30. This is 360 minus 120 minus 150 minus 120, which is 90. Then you're multiplying it by that. Then the answer will be 41.67 years. I think that should be enough for this. Maybe we can do another example. We can sit for another example just in a few while.